This short video will see how to use RStudio to do clustering. As we discussed, clustering is grouping of items, objects, people, products, or whatever it is into different groups of similar characteristics. Now, these characteristics could be one-dimensional or n-dimensional. It can have many different dimensions. Let's take, for example, we want to group NBA players, basketball players, and each basketball player has many different dimensions. In this case, the minutes they play per minute, the scores they make per minute or per game, the free throw percentage, blocks, steals, all these are attributes of the player. So now I want to take all these attributes and then group them into different clusters. So in order to understand this whole concept, what we'll do is let's take an example of a wine where we know which cluster they belong to. And each wine has certain characteristics. And we'll use this clustering mechanism and see how well it does compared to the one that we already know. So here is a file called wine. So you pull up that data wine. Open. So once you know heading, there is yes. So these are different types of wines. So now let's go and look at this data, for example. So you have column type that says A. There are three types of wine here, A, B, and C. There are three types of wines. And each wine has certain content, alcohol, malic acid, ash, and so on. So now the type is already given, so let's keep that out. We don't need to worry about it. But let's take the attributes here, the characteristics, and use those characteristics to cluster them into three different groups. And let's compare how well that clustering works compared to this type. Okay, so that's what we're going to do now. But anyway, we don't use this type. The column type, we don't need it. So one way we can do is we can switch it off. So let's create an So we have view wine, that's what we're seeing here. I'm going to create an alias, wine.f. So wine.f equal to wine, which means I'm creating basically a copy of that table wine.f. And I'm going to switch off wine.f $type, and I'm going to set it to null. So what it does is it basically takes out that column. In fact, if you do view wine.f, and you can show up that it shows up the results on the upper left corner, and you see that there is no column called type anymore. Okay, now if you look at the columns, each column is on a different scale. So for example, magnesium is probably from 80s to 130s. While alcohol is maybe between 12 and 14, while total phenols may be from 2 to 4. So all of them are on different scale. But it's very hard to compare one column with another column when they are different scale. So what I'm going to do here is we'll normalize it. So normalize around mean 0 and standard deviation. So we'll work with standard deviations. So that way it's easy to compare across different columns. So how do I do that? How do I make that into standardize all the columns? Let's see here. I'm going to call wine.stand is scale. I'm going to scale wine.f within brackets -1. So what it does, it basically normalizes this particular data set, so that we can easily compare across different attributes. In fact, if I do this view wine.stand, now I'm going to view that. You see all of them are now, the mean is 0, and then you have plus and minus. So all of them are now easy to compare. Okay, now I'm going to do the clustering. So say results. So I'm going to use k-means clustering. So what it means is that we are predetermining the number of clusters to begin with. That's why k refers to whatever it is, 2, 3, 4, 5, 100. In this case we need 3 because we have type A, B, C. So k means. So the algorithm works such a way that it comes up with 3 means and it allocates each row to different means, nearest one, and it keeps adjusting such a way that it cannot improve the result. So trial and error, it goes on multiple times. So now we have k means, and I'm going to use the wine.stand. That's the view now. Wine.stand is a standardized one, and I want 3 clusters. So you got that results now. I can look at the attributes of results. Results. So you can see the attributes of results are cluster, centers, total standard deviation, within, between a size, and so on. But what we are interested in the cluster in the centers. Let's go back and say results $centers. These are the centers of each attribute. It gives you the centers of each attribute. Okay. Now I want to know how this one is clustered. Now clustering has happened. I want to compare that with the original type A, B, and C. For that we'll use table. So what am I comparing? I'm comparing the original table wine $type. It is still there. If you go here, if you click on the upper end, you can see a tab called wine. So you see the data set still exists. So wine $type, okay, and comma, and I want results. So results $centers. I'm sorry, cluster. That's one of the attributes. Now we have one cluster here. You can see this cluster and centers. So each row has a cluster. So what it does is it maps A with the cluster number 1, 2, 3. Okay. Let's see how it comes out. So now you see the original type was ABC, and the algorithm actually has taken 1, 2, 3, and what it does, it tries to find out how accurate it is. In this case, the algorithm, what we have, the k-means, has put them together as 3 is same as 1. So 59 of the A's have been shown as 3, and it is not misidentified A, 1 or 2, it's always 3. So it's pretty accurate. While B, there is some error here. So B has, the original it is B, but the algorithm takes category 1, there is 1, but 2 is 60, majority of them. 3 is misclassified, as 10 of them has been misclassified as under 3. But C has been very good, so there is no misidentification there. So only error is in B. But let's see what is the error. The error rate in this case is, so there are 11 out of 173 are error, which is a small amount compared to what we can find in real life. So this clustering, this algorithm does a great job in identifying almost 95% correctly. So that's the way you use a clustering algorithm in RStudio.